explain on the introduction of HVAC. First, what is HVAC? HVAC stands for High Voltage Alternating Current, and it can be generated by two types of power generator. The first one is transformer test, and the second one is resonance circuit. There are two types of high voltage, which are HVAC and HVDC.
Why does high voltage necessary for transmission? The network of power transmission must have effectiveness and safety compliance with cost efficiency. To comply with above requirements, electric power transmission is carried out at a high voltage to be able to minimize the power losses and minimize the cost in power transmission. The conductive path in a transmission line is generally made up of aluminium, copper, or its alloy. Accordingly, it may be stated that the power loss that happens in a transmission line is directly proportional to the current flowing through it. The higher the voltage will be, the lesser will be the current. Thus, the power loss also will be lesser. This is the reason why the line voltage is increased to reduce current and eventually the power loss too during power transmission. However, if we will transmit the same power at a lower voltage to the similar distance, there will be more power loss. As for minimize the cost in power transmission, the size of conductor in transmission line depends on the current range it must carry. It is the current that defines what should be the cross-section of the conducting line. If say that quantity of power in transmitting at a lower voltage level, the cross-section of the conductor used will be larger than the cross-section of the conductor required for transmission of power at higher voltage level. Therefore, the high voltage power transmission helps in reducing the quantity of conductor required. It needs no matter that by reducing the quantity of conductor to be used, high voltage transmission reduce the cost involved.
Cascade transformers. For generating AC test voltage of less than a few hundred kV, a single transformer can be used. Meter winding are used to generate and measure the output voltage. Single-phase transformer can be cascade to increase the output voltage. The first transformer is at the ground potential along with its tank. The second transformer is kept on insulators and maintained at a potential of V2. The output voltage of the first unit above the ground. The high voltage winding of the first unit is connected to the tank of the second unit. The low voltage winding of this unit is supplied from excitation winding of the first transformer, which is in series from the high voltage winding of the first transformer at its high voltage end. The high voltage connection from the first transformer winding and excitation winding terminal are taken through a bushing to the second transformer. In similar manner, the third transformer is kept on insulator above the ground at the potential 2V2 and is supplied likewise from the second transformer. Supply to the unit can be obtained from the motor generator set or through an induction regulator for variation of the output voltage.
Other than cascaded transformer, resonance circuit is the other way to generate high voltage alternating current with a given transformer. This process occurs in resonant transformer. Electrical component which consists of two high power factor coil wound on the same core with capacitor that connected across the winding to make two couple LC circuit. Resonant transformer is one of the best choice to generate high voltage, which operates on resonant phenomenon, which is when inductance is equal to capacitance. In resonant condition, the current through test object is very large, and that is limited only by the resistance of the circuit. The waveform of the voltage across the test object will be purely sinusoidal. The equivalent circuit of high voltage testing circuit consists of first, leakage reactance of the winding, second, winding reactance, third, magnetizing reactance, and fourth, shunt capacitance across the output. Next, a voltage regulator of either the auto transformer type or the induction regulated transformer type is connected to the main supply. The secondary winding of the excited transformer is connected across the HV reactor L and the capacitive load C. The inductance of the reactor L is varied by varying its air gap, and operating range is set to the ratio 10:1. Capacitance C comprises of the capacitance of the test object, capacitance of the measuring voltage divider, capacitance of the high voltage bushing, and others. The Q factor obtained in this circuit will be typically of the order of 50. Q factor gives magnitude of the voltage multiplication across test object under resonance condition. Hence, Q factor 50 means voltage of test object is 50 times input voltage under resonance condition. Now I'm going to explain on the advantages and the disadvantages of the SRC circuit. First, no high power arcing and heavy surge current if the test object fails, as the resonance is heavily disturbed by the resulting short circuit. Cascading is also possible for higher voltage, simple and compact test setup, poor sinusoidal output waveforms, and the last one, less power requirement from the main. While for the disadvantages, the step-up transformer has to carry the full load current.
Next, advantages of HVAC transmission system. First, decrease the cost of a conductor. The voltage of the transmission line is inversely proportional to the correct cross-sectional area of conductor. The cross-sectional area of the conductor for a high-voltage transmission line is very small. As a result, the conductor material cost is very low. Second, increase the efficiency. The current decrease at high voltage. As a result, the line copper loss decrease. As the result, the high voltage transmission and total system efficiency improves. That increase the capacity of the transmission line. More power can be transmitted to a transmission line with a greater voltage. Next, disadvantages of HVAC transmission system. Corona loss. With an increase in potential difference, the corona effect increase. The power loss in the line and the disturbance in the nearby communication line are both caused by the corona effect. Second, skin effect. The skin effect causes the conductor effective resistance to increase. It causes more power loss. The skin effect will cause the current density to vary. Third, stability. The stability of the power system is crucial for a reliable power system. It is challenging to create a stable system if the line length exceeds 500 km. The line length is hence the limiting element. Next, heavy support. Heavy and sturdy support are needed if the distance between two conductors and the distance between a conductor and ground increases. This raises the transmission tower cost. Reactive loss. Both inductance and capacitance are included in transmission line impedance. They are both directly opposed. While the other is leading, one is lagging. Operating the line at its natural impedance is not possible. There are net reactive losses. Ferranti effect. Due to the capacitance, the charging current will pass through the conductor. The voltage of the receiving end increases more than the voltage of sending end as a result of this charging current.
Now I will explain the difference between HVAC and HVDC. For HVAC, it is suitable for overhead power transmission at distance below 600 km, which is economical. However, for HVDC, it is used for long-distance bulk power transmission, including underwater as well as the asynchronous interconnection between AC grids. And for the second difference is the HVAC transmission is used for less than 600 km distance, but the HVDC transmission is used for transmitting bulk power more than 600 km distance. The third difference is the effective power transmission capability in HVAC is affected by reactive power losses. However, there are no reactive power losses in HVDC transmission. And lastly, for the fourth difference is the conductor are affected by corona losses. It requires a large diameter cable due to skin effect. But the corona loss in HVDC are reduced by a factor of approximately 3. The current stays uniform in cable, thus it can use comparatively smaller diameter cable. In conclusion, the HVAC gives a lot of benefit to us, but HVAC and HVDC both have their uniquity and specialty in transmission system. The HVAC transmission system is a conventional system to transmit power for long distance. However, HVDC transmission system is developed to overcome this disadvantage of the HVAC system. That's all from us. Thank you for watching.